Hello, I'm Robin Shute, 4 times winner at the Pikes Peak International Hill Climb. Today, I'm actually going to be sharing something quite exciting with you. You may or may not know, I am both a driver and an engineer. And what took me over to the United States all the way back in 2011 was to work for a little-known car company at the time called Tesla Motors. And from there, I've continued to develop myself both as an engineer and as a driver. Now, back in 2018, me and a group of friends formed a team called the Sandy Club, and we created this car called the Wolf, and we took it to Pikes Peak, where we raced it first year not so successfully, but thereafter very, very successfully, winning in 2019, 2021, 2 and 3. So they're the 4 wins. We took this car, which was based on our Wolf GB08, and we basically hot rodded that to be the ultimate mountain racer that we could create ourselves. This group of friends are also professional engineers, and we just kept tinkering and just making this car faster and faster and faster, to the point of being an absolute force to be reckoned with. And we got to this place, I would call it diminishing returns, where we're putting more and more time and effort into it and not getting as much performance as we used to, as much performance gain. So it came to the point where we had to consider maybe it's time for a new car, and that's what I'm going to be talking to you about today. Is the project I am now currently working on and pretty deep into is going and creating an all new car from scratch. So yeah, the Wolf has been absolutely fantastic, but we really are getting to the limits of what we can do with it. And I mean, I've been aware of this for a while now. This car we started back in 2018 and it's now 2024, so that's 6 years I've been working on this thing. And you realise some of its shortcomings and limitations, and to go and improve on those was going to take so much work and effort. It made more sense to start again with an all new car. And I started to actually get these designs onto a computer screen back in Christmas 2023, and I've been working pretty diligently on this since then, coming up with a vehicle concept and really kind of going into fine detail of what this car is going to be. And really I've come up with this car as the ultimate Pikes Peak racer, at least with what I can build with my resource. And not only that, I'm trying to build this so it can set outright lap records at pretty much any race circuit around the world. So what I want to show is when you remove a rule set, great things are possible. And that's where a tiny team, like, majority of this car has been designed by myself, but then I've got the support of absolutely fantastic partners and also other team members to go and design and make this thing. But this is, not a full-time job, it's a part-time job and a passion project. But what I want to show is by doing that and doing it with really great people and really great partners, you can make a car that's so special and so much faster than what is regarded as the best out there right now, and really how limiting rule sets can be also. So I sometimes describe it as a bit of a punk rock grassroots effort to show really what can be done with a small group of talented people. So yeah, this is part of that and following along with this journey. So my aim with these videos is to try and run through the whole design, build and development process. So I'm going to be doing my best to do this in this vloggy style, where I'll be talking to the camera and sharing what I've been going through and what I've been doing, and I'm going to try and support that with some pictures, diagrams, maybe video along the way to help give you an understanding of what I'm focused on, what I'm thinking about, and explaining some basic concepts, some engineering concepts, and maybe a few advanced things that nobody's got an idea about, or nobody has an idea about because I'm making stuff up. Anyway, no, it won't be like that. So this first video, I'm going to touch on a very high level overview of going about designing a new car. It's a very open-ended task and quite a daunting problem, and you really have to go and define that problem and figure out your approach to go and do that. So this is what I'm going to run through at the moment. And going and doing this new car wouldn't have been possible 6 years ago because we didn't know what we didn't know. And those 6 years of experience have been so valuable because we've tried a lot of things and a lot of things have worked, but there's been a few things that haven't worked so well also. So that's been really helpful and really valuable when going and starting on an all new design. So the first step in the process has really been to understand the strengths and weaknesses of our previous car, the Wolf. And the first big thing about that, and I know it's a controversial one with the people in the race, is whether all-wheel drive or rear-wheel drive is the quickest way up the mountain. The record has been set by an all-wheel drive car pretty much exclusively for the last 30 years. Reese Millen in the first year of Tarmaker's time attack car was maybe an exception to that, and I think Paul Dallenbach with his open wheel stuff, but around all the rally cars, and then the Pikes Peak monsters that Loeb had with his Peugeot, and then Dumas had with the IDR, they have all been all-wheel drive. The analysis I've done and what I could see, when you stick to a very lightweight vehicle, and we're talking below 1,500 pounds with driver and fuel and fluids, the difference in mass between an all-wheel drive system to a rear-wheel drive system is significant. We're talking in the region of about 150 pounds, which is a significant percentage of the mass of the car. So that's something really to be considered. And then the next thing is, when we're talking all-wheel drive, we're thinking traction, and how much is traction limit causing us an issue coming off the turn on the mountain with a rear-wheel drive concept. And what we can see in the data, actually traction off of these hairpin turns with a rear-wheel drive is really quite good, and most of that is more dictated by engine response and turbo lag off of the turn, and this is why you see Porsche 911s being so fast with their rear engine layout. They have a lot of traction on the rear axle. So what it appears to me is that rear-wheel drive will work so long as you do have a significant amount of weight, mass over that rear axle to create the traction to start with. So that's something to consider in the vehicle design, is that, okay, well, we're going to have to move that weight further rearward. Depending on the rule set, and that typically is dictated around aerodynamics, you often see circuit racers bring the balance forward to get a better front end, because it's easier to make aerodynamic downforce on the front, so bringing that weight forward, because the low speed turns are much fewer and further between. But on the mountain it's really quite different, and that more rear bias setup is better. So I think the sweet spot's around the 40, 60, 30, 70 region. We started off with the Wolf actually a little more rearward, and we brought it forward, and you do see the trade-off in the data there. But what I will say about all-wheel drive is its strength is coming off these mid-speed corners where you're rolling on the throttle. We can see that essentially it's the second timing sector, so the end of the bottom qualifying section on the mountain, where the IDR does a very, very good job of rolling on the power and basically using the torque vectoring of the front axle, because the front axle is steered with the front tyres, to pull it off the turn like that. So that's where I think rear-wheel drive struggles the most. The other thing to consider is all-wheel drive is also expensive, and so not only is it an added mass you've got to bring along, it's also an extra cost and development time I've got to go and put into that. So I've chosen to stick with the fundamental layout of the Wolf with this next car. There's been some subtle changes in the driveline to help this concept more and bring some more traction to it, which I'll run through at another time. But ultimately, the concept of the car being that mid-engined, and then the gearbox behind it, and that structural gearbox behind it, and being a lightweight car, so below 1,500 pounds is staying and sticking. And I think that's the best route forward, especially for what I can do. So that's a big one. The other strengths of the Wolf is its downforce to weight ratio. Often you hear, aerodynamics is quoted really poorly, and it's very hard to understand. And there's some first of all some basic things around where, when we hear forces quoted, what speed it's at, because aerodynamic downforce is completely dependent on the speed, and it's actually dependent on the square of the speed. So if you double in speed, you'll get 4 times the load, 4 times the force. So that's significant there. That's reasonably well shared and understood, but typically makes it hard to compare apples to apples. The value that I find are much more helpful to go and compare is what's called an SCZ number, which is your coefficient of lift times your frontal area. And you can basically use this quantity to give you the total downforce of the car at any speed. It's really helpful. So that's SCZ. And that's what I've been tracking. I've got a whole benchmark sheet of a whole bunch of cars of where they are in terms of SCZ based on information that's been available publicly. And then the other thing which I think is considered a lot less is the downforce to weight ratio, and that really describes how potent the aerodynamics is on a car. If you have a 2-ton car, and that's actually a lot heavier than that was the Hyundai Ioniq 5 I was driving previously, the amount of downforce you have to make to make that car feel the difference is proportionally more as the weight of the vehicle. So it's actually worse than this. But if you've got a car twice the weight, it needs twice the downforce to give you that extra cornering potential. And that's assuming the tire can take it. In reality, that's normally not the case. So a tire is non-linear, so the more load you put on the tire, the lower the coefficient of friction becomes. So it's that diminishing return there. Another reason why light cars do so well is it's typically really in the sweet spot of the tire, and the car responds to a little more aerodynamic load with the tire because the tire has the capacity to go and do that. Anyway, that's complicated. Digress. I'll get into that more on another video. So the Wolf was really good because its power to weight was about 600 horsepower and weighed about 1,500 pounds. And then its downforce to rate was phenomenal. It's probably making its weight in downforce at sea level about 70-80 mile an hour. I need to go through the notes. 70-80 mile an hour. On the mountain less, because of the lower air density, it proportionally changes that as well. So there are the big strengths of it, I think, and its weight distribution. So that's what I wanted to carry through onto this new car and optimize and improve, basically. So understanding the strengths and the weaknesses. So weaknesses we'll touch on, and that's the big one I think with the Wolf was its engine response and its size of turbo required to make the power it did. Meant that that we revved the engine to 9,000 RPM. With the turbo we were running at sea level, that turbo would come on about 4,500 RPM. At the bottom of the mountain, it's about 5,500 RPM, and by the top you get into about 6,500 RPM. And at that point, you're really struggling for usable power and getting that thing to come on cam. And that's just a feature of, imagine that the problem with the turbocharging is as you go up the mountain, your engine essentially gets smaller, as does the turbo compressor gets essentially smaller, but then the turbine gets proportionally bigger. So you get to that point where the wastegate is slammed shut and there's no more exhaust energy to turn that turbo. And so that's where, turbo sizing, when I say on the mountain, is like Goldilocks. It's got to be not too big, not too small, basically. So that I would say is a big weakness. And then we're just looking to improve each of the metrics and move it on a little bit, improve a bit more power, a bit more torque, a bit more engine response, more drivability out of the engine, a bit less weight, a bit more download. These are all things that we're chasing that is hard to get any more out of the Wolf right now. So from those strengths and weaknesses, it's identifying then the opportunities. What on the Wolf is kind of inherently flawed, and how can we go and improve that? The first one was, the Wolf was created per the rules it was racing at the time as a 2-seater. It has 2 mounting points for seat belts in it, so it's a wide tub. That means you're giving up some things, both aerodynamically and weight-wise. So going from this 2-seater setup, where I was sat on the right-hand side of the car, to a single-seat, center seat layout. that left to right weight distribution does actually make quite a big difference as well, especially under braking and traction. The next one is the engine. The Honda K20, we were getting to the point of, you know, really being a wear item. We were being as kind as we could to it, and it was still only lasting 300 miles. You know, when you're having an engine, you're making that much power. And I know drag racers say, oh, we're making 1500 horsepower, 1000 horsepower with it, good and great, but you're doing that at like 9 seconds at a time. We're doing it for 10 minutes at a time, and we're really pushing this engine, and that, you know, 550, 650 horsepower takes its toll on the engine. We're also putting a lot of load through it because it's semi-structural, you know, so we're seeing cracked blocks and things like that also with that engine. It's having a tough time. The oiling system's not quite keeping up, and then you know, the main thing of the torque band, where it's, you know, to make the power we need to make to be competitive, that torque band becomes quite narrow, and that ends up hindering us out of the hairpins. So that, you know, with that requires a new engine, and you know, this will be another video, but a fun task of basically looking all the way around the world and seeing, well, what's the best thing we could put in the back of the car that's obtainable. The next one is more efficient aero. The Wolf, we started off, you know, that was designed for 250 horsepower with quite a strict rule set. It makes a lot of downforce in stock form, but when we're talking about Pikes Peak downforce, it's nowhere near where we need it. Also, that aerodynamic package has been designed to run at a very low ride height, and that's what you can't do on the mountain. You have to run the car a lot higher. So with no rules, there is a huge opportunity to get a lot more efficiency and a bit more download out of the car. And yeah, we could take advantage of that with a you know, a full ground up build. So that was a big opportunity also. So when I say efficiency, that means more downforce and less drag. We have a lift to drag coefficient, that's how that's expressed. So we want to keep to be in the similar region of downforce to weight as the Wolf, but then make a lot less drag out of it, so we can have better performance at the higher speeds. And the last one, and this one I love, back to my Lotus roots, and that is simplify and add lightness, reduce weight. And that's always something I'm striving for. The Wolf, as we started to develop it, became more and more complicated and got a bit heavier and a bit heavier and a bit heavier. And as good as it is adding performance in certain ways, you then remove it from others. So I really want to remove that compromise and make this car as simple as possible. And that has knock-on effects everywhere. You know, the big ones for me, aside from what we've heard before, is, well, it's fewer parts to design and make. And then there's also fewer parts to pay for as well. So that has other huge program implications on top of it. So really good. So that's it. You know, there we're identifying the opportunities. And the next thing to think about is picking the right tools and also partners. These things are absolutely key. And without these, this car would never be as good as it's going to be. It's all about, this is where the engineering work goes into it. The big one is aerodynamics, as you can see on Pikes Peak cars, and what I'm about as well. And I've had a huge performance upgrade in the program since I've been working with a tool called Airshaper. This tool is absolutely fantastic. It allows, you know, engineers like me who have quite a lot of experience in aerodynamics and the theory and how it applies to cars, but I am not an aerodynamicist by any means. So I have enough knowledge to be dangerous. But that means like CFD tools, things like that, aren't really accessible to me in the traditional sense because they cost so much. You need to be doing that all year round, providing services to people, and it also is quite complicated, quite a complicated process to go and get that really accurate. However, with the tool, with the very open rule set I have in Pikes Peak, actually I'm not focused in on the minute detail, but I'm actually focused on a much bigger picture of what I can get out of the car. And this is where Airshaper works so well for me, because it's a very quick and easy tool to go and use. I can go and create a CAD model. It's a very rough, unpolished, dirty CAD model, but I can literally just upload it into a web browser, and then online this Airshaper tool will go and essentially recognize all the surfaces, simplify it, and then go and create a CFD mesh around it that can go and run using the open foam code. And it also is able to set up very simple, or what would be difficult, but very important, but quite simple things of moving road and rotating tires. And then also what's been super helpful is the porosity feature, which essentially is how you go and model heat exchangers, coolers, radiators in the car. So I can get to a really good concept point with that before handing that over to a very experienced aerodynamicist. And with all the other compromises I am making on the car, this allows me to do a full system engineering on it as a single person. And I think that's a strength in this project, is I'm not having to go and design by committee. I can be very focused on what I need with all these tools around me. So Airshaper is a huge one. We'll go into a lot more detail with that. The other partners, I've got a really great engine partner. I won't say who they are now because that's another episode, but they've been absolutely fantastic. I'm excited to talk to you more about what the engine is going to be. The other one is Alcon with the brakes. Had recent experience down in the Hyundai program, and I could see how much of a huge difference that made to the braking performance of that car. In a lot of situations, that 2.5 ton Hyundai was able to slow down quicker than the Wolf. So I think that's really telling on how important it is for a great brake system. The brake system we were running on the Wolf was designed for a Formula 3 car where they barely ever use the brakes. So we were way past the limit of what those brakes were capable of, and they were still holding up. So really excited to get a proper product on the car that's sized exactly for what we're doing. That's exciting. Next one is gearbox with Sadev. We've been using the Sadev gearboxes all this time in the Wolf, and they're just fantastic, especially bang for the buck. They're not cheap items. You're still paying a good dollar for them, but the value you get out of them and the quality you get them is so good. I wind these guys up all the time by putting too much torque through it and too much RPM through it, and it just holds up. They're always telling me to slow down, but I ignore them. But yeah, that gearbox has just been a strength of the car, and we're going to continue to go and use that one of their gearboxes, actually a little gearbox this time. I'll explain why I've picked that gearbox. And then to go and design this, I'm doing it all on a 3D CAD package called Autodesk Fusion. It used to be called Fusion 360, and that's been super helpful with what I need to do. It's not as good as, say, things like CATIA V5, which I used previously for ultimate precision, but when it comes to using a lot of different file types and kind of like design sketching and throwing things together very quickly is so good. And ultimately what it lacks in a bit of precision, it makes up for so much so in all the other areas of going from an idea in your head to a completed part on the screen. So that's been a huge enabler for me. Thank you for joining me on this. Feel free to ask any questions. I'm probably not going to answer any specifics about what the car is, but I will answer Pikes Peak related questions, engineering questions, all that good stuff, as I want to share with you my knowledge, experience, and also take you along for this fun journey. See you in the next one.